This is Eric Parziale doing Unit 6 Calculator Inactive Test Corrections. Okay, so the first problem that I missed a little bit of was number 1. The part of the problem that I missed said, given y equals 2 times the quantity of 1 minus cosine theta, find dy over d theta. And I missed 6 points on this part of the question. The problem was that I miscalculated dy over d theta because I failed to distribute the 2 in the factor. And so, I mean, once taken into consideration the little mistake there, it's pretty easy to solve. And you have y equals 2 minus 2 cosine theta, and dy over d theta equals 2 sine theta. Okay, well, the next problem that I missed was, given the polar curves r equals 3 cosine theta and r equals 1 plus cosine theta, determine the points of intersection of the two curves. And I missed 5 points on this part of the problem. And my error on this problem was that it said find the points of intersection, but I only found the values of theta for which the curves intersect. Okay, to solve the problem, you set 3 cosine theta equal to 1 plus cosine theta and solve for theta. Work it out a little bit, and you get down to cosine theta equals 1/2. At this point, you use your little table that you learned in pre-calculus. You look in the table, and you see which value for cosine theta is equal to 1/2, and you get the value right underneath 60 degrees, which is also pi over 3 if you work in radians. And so cosine of theta equals 1/2 when theta equals pi over 3. If you draw your little unit circle, you see that the pi over 3, the cosine of pi over 3 is equal to the cosine of 5 pi over 3. So those are the two values of theta for which the two curves intersect. If you plug in pi over 3 or 5 pi over 3 into your original equations, you get r to equal 3/2 in both. Thus, the points of intersection for these two curves would be pi over 3, 3/2, and 5 pi over 3, 3/2. And that concludes my BC corrections.